now we are going to the Q&A session, and I would like to invite all the presenters. Could you please unmute yourself and share my screen? Yeah. Could you please unmute yourself and you can accept our questions from the audience. Any questions from the audience? So I have a very quick question for the team from UZ University. It seems that contrast learning significantly improved the model, and you know, other teams are like using ensemble models. May I ask how many models do you use for the submission, and what's the gain, and what do you think? So you briefly talked about contrast learning and how or why it works. Do you have more comments to share with us?
Okay. We've used we divided the Trainville data set into the five set, and then we for the each split we trained the best model for it, and we already have 5 models from that. And also we applied some very basic baseline for our ensemble pool, something like just direct pass using transformer encoders or comp1Ds or like that. So for all, we approximately have about 20 models for final submission.
Okay. Yeah, that's a lot.
Yes.
Okay, but you consistently observe that contrast learning is beneficial for this.
Yes. For the single model's performance, we observed that the contrast learning approach result in the best performance.
Mm-hmm. Okay, and it also adds benefits to the ensemble model, right?
Yes.
Okay. Very interesting, and I think more studies can be analysis or other contrast learning methods can be applied to this task.
Yes, we adopted the same approach, but we thought that other approaches can be applied to our method too.
Yes, absolutely. Any other questions? I also have a very quick question for the ByteDance team. So so from your presentation, I think it's all other teams are not using audio, right? And we're using audio signals for the boundary detection task. And from the results, it seems that audio is performing really good. I mean, even comparable to the RGB stream, and this is not a little bit different from the recognition side. For example, for action recognition, usually audio is not very good, but it adds a huge benefit to the ensemble model. But this seems, in this case, audio is also very good. Do you have any comments to that? And for example, did you try to add simply ensemble audio to the baseline model or the CSN model, and what's the benefit of adding a single audio stream? This is the question for the ByteDance team.
Okay, sure. We use audio just for a small component. We found a part of actions, the audios can help to split the boundary, such as the clean and jerk.
Mm-hmm.
The human will have the audios in different action stage, but in some other action, the audio may not have the help. So in our experiment, the audio only improves our model by 0.007.
Okay.
So it is a very small improvement.
Mm-hmm.
We don't have tried the audio for the larger model. We just have a little trial of this. Yeah, I think it is. We can do further study of the audio stream.
Thanks. Thanks for this explanation. Other questions from the audience? If you do have questions, you can just raise a hand or type in the chat box. I have a quick question for the Oppo team. So you're using like person detectors for Fusion or for Ensemble. So but the person detector performance is like 63. It's quite good, I have to say, because the detectors are, I think the detectors are pre-trained, right? And it does not have like because it's only detect person. So from the results, I think you ensemble many models. So a quick question is, how many models did you ensemble, and is there any specific model that is really strong that you may share with us?
We ensembled in total 8 models, 8.
Oh. Mm-hmm.
And the strongest model is I show that in my PPT, in my slide, the temporal localizer model. It combined with the boundary classifier, and actually it's that we are using a sliding window in test data. So it's like a top-down. It's like a top-down method to get a coarse temporal proposal. Then we have a BMN in. We have a BMN. It's a bottle to up method. So it's like a refinement network to give a more precious boundary proposal in our method.
Okay.
Yes. So it's a combination of a classifier and the localizer.
Mm-hmm. Sounds good. And so there's a question from the chat. I think that's not related to the speaker. Yes, our reports will be available to all the reports will be available in the website, in the workshop website. And so we now go into like a bit more general discussion on this specific task, and I think Frost also done some brilliant works in like evaluating the downstream tasks. And all the other 3 teams have been working on this. And what's your like experience, or what's your thoughts on like using boundary detection for other tasks? Forest has some experiments, and maybe other teams can also share some lights, or maybe because you actually work on these data sets and you have some in visualizations or hands-on experiences, and how do you think this data set will be benefit to the downstream task, is or how what else other other what will be the other applications or other downstream tasks that maybe it's worth a try.
Okay. Thank you, Lin Shao, for the question. Actually, I've been working for temporal action localization for multiple years, I would say. And from my observation is that now the majority of the submissions to our ActivityNet challenge are following the two-stage method. So for people who haven't heard of ActivityNet, so it is a similar challenge to LoveU workshop, but the task here is for temporal action localization. And the BMN model, for example, that Sun Quan used, got the second prize in our previous year. And the current methods are also mostly it's like a variant of BMN method. So we are trying to use different model architecture to explore the like temporal semantics in the video. Because we are working on temporal action localization, which we focus on temporal local sensitivities. And that's something I find is missing in current long form video modeling. Because now, as I mentioned before, people are using the pre-training method. And in pre-training, we only have the classification data set for pre-training. And that's why at the beginning, we have to use some kind of trivial method that to extract the features and use the feature to build some simple model to localize the activity. I still remember that in like 2018, the first model that looks have a very good number in BSN, that it actually classifies a combination of starness and endness score, and the input to its classifier, it's from the actionness score, where is a one-dimension vector. If I remember correctly, is a feature vector with 32 elements. So by only use the 32 element feature vector, we can say if the action is it's a localized action or not. This is because their model are trying to measure the sensitivity in boundaries. And then followed by BSN, the same author applied BMN on the task, and it works much better. It's much better because they try to make the gradient backprop to the first backbone. So their first backbone is some way to predict the start and endness. And in BSN, the early method, it's also another two-stage method. And so the idea is that if we can make the gradient backprop to the startness and endness prediction model, and we can find the joint optimization is better for the task. But now, what if we can try to optimize the gradient to our initial backbone? But if people join the Andrew's discussion in his recent work, he shows that it's very hard to model the long-term videos because we have the memory issue. If the video is longer than 30 seconds, it's like impossible to feed every frames into the memory. So we have to come up with some alternative method to pre-train our video encoder. And in Andrew's talk, he gives a very interesting method to use the selected update. So randomly select some frames to update. That's one way to make the gradient backwards to the video encoder. But given the generic event boundary data, I would say it's one way is we can use the generic event boundaries to train a real boundary sensitive model and try to apply it on several applications. And as for the applications that we can use for the downstream task, to answer Lin Chao's second question, and temporal action localization is one method, and also as shown in my talk, so one is called video grounding. So video grounding is that we are given by one video and one language, and we try to localize where is the most relevant moment that related to the language. And also I would say the video captioning is also one application to the generic event boundary dataset, because in video captioning, what we have is a long video, and what people usually do is we find some try to trim the video, cut the video into different chunks, and we run some captioning model on each chunk of the video, and then we try to summarize the video. And here, what I can see, if we have a better boundary sensitive model and we can have a better chunk, and then the better chunk will lead to a better captioning than a better summarization. Yeah.
Yeah, I think the conclusion is that maybe the boundary detection data sets can be used for long videos, where it is not easy to like localize or pinpoint the exact event. Then you need to trim the video into segments. So that's where the task or the data set will be useful. What about the others? Do you have any thoughts on the application side of the boundary detection on task, or you have anything you want to share during the hands-on experience during the competition? Maybe we can start from Opal, and then the BIDOMS, and then the Yonsei University team. So, for example, Shuming, I think you're doing very good job in in this task. And do you have any thoughts on the potential applications in your product? For example, just a guess, maybe because you're interested in this competition and you're from Opal, and I think you may thought of maybe used for your applications. Do you have any thoughts on the potential applications, specifically maybe in Opal? No? Okay.
Okay, thanks. I think it's it is a basic technique for long video understanding.
Yeah.
Yes.
No worries. No worries. Anyone else want to share? Yeah, I think that's maybe it is a general task, and maybe there's lots of potential applications. For example, symbolization, and also other video grounding tasks Frost has already mentioned. Do you have anything you want to share? If no, I will summarize the workshop. Any questions from the audience? No? Okay. Okay. Thanks. Thank you for joining the Q&A session, and congrats on your very good results. Thanks.